So what do these acronyms really mean? We have AR versus VR, augmented reality versus virtual reality. So when we talk about augmented reality, it's the digital world with the real world actually in digital with the digital information overlay. So you can use this viewed through glasses or cell phones. Versus VR, which is virtual reality, is a completely digital environment. So you're fully enclosed, fully immersed in that digital environment. We can also look at MR versus VR, XR, mixed reality versus extended reality. So you have sitting between AR and VR is mixed reality, which is where the presenter, where the user is interacting with virtual objects and can be integrated into the real environment. And on top of that, it's extended reality. So this is a good kind of overview of what extended reality is, which is encompassing of augmented reality, virtual reality, and mixed reality. And my colleague Sesmet Powell will be going over more in depth each of these different technologies. Going back to the acronyms, we also have AI and ML, artificial intelligence and machine learning. So artificial intelligence and machine learning are often used interchangeably. However, machine learning is actually a subset of AI. So you look at artificial intelligence, it refers to the general ability of computers to emulate human thought, perform tasks in the real world environment, make decisions, analyze data, solve problems. While machine learning refers to the technologies and algorithms that enable the system to do so. So if computer programmers and software developers, they're enabling computers to analyze the data and solve problems, essentially creating artificial intelligence systems, and they apply tools such as machine learning. They can also use deep learning, neural networks, computer vision, and natural language processing, which is a whole different subject which we won't go over. But that's the difference between AI and ML. And then lastly, we can't talk about AR, VR, MR, XR without talking about meta and metaverse. So meta is a digital space where people are connecting with each other. Meanwhile, they're not physically with each other, and more on that later on as well. So now let's take a look at the timelines. Where did this technology and how did this technology actually evolve? And believe it or not, it actually started in the 1800s. In 1838, scientist Sir Charles Wheatstone outlined the concept of stereopsis, or binocular vision. This is where the brain combines two images, one from each eye, to make a single 3D image. This then led to the development of a stereoscope. It's a device that takes the pair of those images and transforms them into a 3D image, creating that illusion of depth. And that's where the stereoscopic displays are actually used in VR today. In 1935, jumping through the 1900s, this is when the American science fiction writer Stanley Weinbaum published Pygmalion Spectacles. In this story, the main character actually uses goggles, a pair of goggles, to view a fictional world. So this is where the prediction of the VR as we know it right now. In 1956, cinematographer Morton Heilig created Sensorama, which is the first VR machine. This is essentially a movie booth that combines 3D images, color video, with audio, with a smell, with also a vibrating chair. So you're fully immersed into that movie. And it's like the first VR machine. And in 1968, the first AR headset was created by Harvard professor Ivan Sutherland. and it's called the Sword of Damocles. This headset is displayed computer-generated graphics. It enhances the user's perception of the world, which again is an early precursor to the augmented reality experiences that we know today. Moving on to the 1980s, this is where iTap was first developed, which is the first portable AR device. It has superimposed a picture onto the real world, which then includes a computer at the backpack to support it. In 1987, Jaron Lanier, he was the one who first coined the term virtual reality, and he created the iPhone glasses and Data Glove. In 1993, the 90s were really a big time for game consoles. Then in 1993, Sega released its Sega Genesis, which is a headset, but then it really unfortunately only remained in the prototype stage. And then finally in 2007, Google released the Street View, which is the 360 view of the different locations, really pushing us forward to where we know of AR, VR now is today. So at this point, I'm going to turn it over to my colleague, Sasmit Pal, and he'll be taking you through the technology evolution and the industry use cases of the technology.
Thank you, Dr. Elias. And thanks everyone for this opportunity. My name is Sushmit Pal, and I will be talking about some of the technology options and some of the industry use cases for AR, VR, and immersive technologies in general. So let's do a quick recap of some of the terminologies that Dr. Elias shared. Virtual reality, augmented reality, mixed reality, extended reality. And there's a lot of overlap between each of them. So to describe this, it's really the reality virtuality continuum, which says that these terms are interrelated, and this is a spectrum. So if you start from the right-hand side, virtual reality, it is a complete recreation of an environment. So you are fully immersive, you are fully cut off from the real environment, and you are in this synthetic experience with no sense of the real world. The headset that you'll be using will be fully enclosed and will digitally create a completely different environment from where you are. This is great for use cases where you need the user to be fully engaged, completely not distracted and focused on just one application. And so it's been used a lot in training, also in creating different scenarios where you can transport the user to a different destination, maybe on a beach or in space or maybe inside the operating room. So recreating that environment will be something that you would do in virtual reality. It's also highly interactive. The user can see different objects. They can interact with those objects. So there's a lot of flexibility there. On the other end of the spectrum, on the left-hand side, is augmented reality, which still keeps you grounded in the real world. So you can see your surroundings, you can see physically where you are, but you'll be able to digitally overlay some information on those physical objects. A really good example of this is the game Pokemon Go, where you can take your cell phone and as you walk around, you see your street and you see the buildings in your neighborhood, and you can go and collect Pokemons. You cannot interact as much with the layout, but it does show you a good sense of the real world while overlaying some of these objects or Pokemons on top of it. It's a great example of augmented reality. In between the two is something called mixed reality, where you use a headset that still lets you see through. So it's a transparent headset where you can see your real world, but at the same time, you are overlaying some digital objects on your physical environment in the form of holograms.